Hi, welcome to the channel. I'm Mrs. R. Let's do some math.
Welcome. Today we are talking about work word problems. Now, these word problems always have some kind of job that needs to be done and some combination of people. Now, we get a little bit of information about how quickly each individual person could do this job, but then we also either need to find or we're given some information about how quickly they could do this job together. So we're going to do two examples to kind of work through two different ways that these questions can be posed. The first one, we have Ryan, who, when working alone, can dig a 10-foot by 10-foot hole in 5 hours. Now, Castle can dig the same hole in 6 hours, so the same size hole. How long would it take if they dig the hole together? So basically, we're going to look at the rates that these people would complete this and combine the fractions. So we'll start with Ryan. Ryan can dig this hole in 5 hours. So we're going to make a little fraction for him that says 1 hole, 5 hours. That's Ryan's. Now we're going to add that. We're going to combine his work with Castle's work. Now Castle, though, he can dig that hole in 6 hours. So it's still 1 hole. It's that same 1 hole in 6 hours. And this will give us their combined work. But since these are fractions, as you know, we need to get a common denominator before we can add up these fractions. So the quickest way to find a common denominator is to just multiply your two denominators. That might not be the smallest or the least common denominator, but it will be common at least. So I'm going to take this fraction and multiply by 6 over 6. And the second fraction I'm going to take times 5 over 5. So we end up with Ryan's ratio of 1 hole for every 5 hours is equivalent to digging 6 holes in 30 hours. And then we can add that to Castle's, where we get 5 holes in 30 hours. So now we have them in the same time, and now we can add these. So 6 holes in 30 hours plus 5 holes in 30 hours, that would be 11 holes dug in 30 hours if they were both digging. Now the question is not how long would it take them to dig 11 holes. The question is how long would it take them to dig 1, right? We are digging 1 hole. So there's one last step in this problem because we don't want 11 holes, we want 1. So we're going to divide by 11. And at the bottom, we're also going to divide by 11. And this will get us an equivalent ratio for 1 hole. Because 11 divided by 11 is 1. So then we just get out our calculator and we say, what is 30 divided by 11? 2.72 repeating. So you can either write that as 2.72 with the bar over it, or if you're rounding to the nearest hundredth would be 7.3. Now, if you're asked for minutes, like hours plus minutes, then there's a conversion there. But this 1 hole in 2.73 hours, that really is sufficient for an answer most times. So how long would it take them if they worked together? 2.73 hours. Obviously, if they're both digging, the work goes a little faster. All right, we have a second example we're going to do. This one you'll see pretty quickly is asked a different way. So we have Crystal, who can wax a floor in 16 minutes. Okay, there's a rate we can use, right? We've got Crystal and 16 minutes. So 1 floor, 16 minutes. That's her rate of work. And we're going to add another person's work there. One day her friend Perry helped her, and it only took 5.7 minutes to wax that floor. Then the question is, how long would it take Perry to wax the floor alone? So Perry's over here, but how long would it take is what we're looking for. So we don't really actually know Perry's work rate. 1 floor in X minutes. We don't know how quickly Perry works. We do know that final total, though. We know that total, when they worked together, it only took 5.76 minutes. So I can fill in that together combined work rate here, one floor in 5.76 minutes. So really, if you look, it's definitely different than the one we had before. The solving method's going to be different, but there's only one thing missing in our equation. We've got numbers everywhere else, so this is a solvable problem. Now, what I would do is go ahead and get the ratios that we know on the same side. So I'm going to subtract the one floor over 16 minutes from both sides. So we won't see that on the left. The left side now will just be the unknown work ratio. Perry's ratio of one floor for every some number of minutes. And then on the right-hand side, we have that combined ratio, one floor in every 5.76 minutes. And we have this subtraction now where we're subtracting basically Crystal's time. So one floor in 16 minutes. Now, I do not recommend trying to find a least common multiple for 5.76 and 16 because we've got a decimal there. That's going to be pretty challenging to find a whole number. Both of them are factors of. So in order to actually do the subtraction, we do need the common denominators, but I'm going to use the same strategy we used in the first one, where I just multiply each ratio by the other denominator. So that first ratio, one floor over 5.76 minutes, I'm going to multiply by 16 over 16. Then the blue one, one floor every 16 minutes, we're going to multiply by 5.76. So we're going to get some strange numbers, or a strange number, but it will at least be the same number. We'll have things in the same unit. So we're still missing this whole one floor Perry rate. And we'll need the calculator for this one. 5.76 times 16. So our combined rate, we could do 16 floors in 92.16 minutes. And then we're going to subtract Crystal's rate. Since we're multiplying by 5.76 there, she could do 5.76 floors in that same 92.16 minutes. I'll bring the calculator back in a minute. So now we have our common denominator. So I know this is going to be something over 92.16 minutes. But how many floors would this be? This is going to end up actually being Perry's rate. So we're going to do 16 minus 5.76. 10.24 floors. So you give Perry 92.16 minutes and they'll get 10.24 floors waxed. It's a little awkward, right? But honestly, we don't care about how quickly Perry can wax 10.2 floors. We want to know how quickly Perry can do one floor. So we'll divide both of these numbers, get an equivalent ratio, but we want it to be one floor. So we're going to divide by 10.24. So that top numerator comes out to be one floor. And we'll get our 92.16 divided by 10.24. And doesn't that come out nicely? So it looks like Perry can do one floor in 9 minutes. So that would be our answer. Now you can apply this for 3 people or 4 people or however many people are combining their work. You'll just add that many ratios for each of their work rates. Now I do want to make a note here. When we were here with our 1 floor over X minutes equals 10.2 floors over 92.16 minutes. This is a proportion. So if you really just enjoy working with proportions and multiplying both sides and then solving for your X, you are absolutely welcome to solve this like a proportion. Now, I did not. I used a different strategy here. I found it an equivalent ratio, but either way works. Either way will get you to that 9-minute answer. So thank you so much for joining me for this talk about work word problems. If you found this video helpful, please hit like on the page. That'll help our videos reach more people. And if you have any questions still, or you want to see a different concept on the channel, then just leave a comment for us and we'll try to get that done as quickly as possible. But I'm Mrs. R. We've come to the end of our video of me doing math. Thanks a lot, guys, and I'll see you next time.